Let's start very simple. Say you've got a quantity in centimeters and you want to convert it to meters. Now you probably know that you can just move the decimal point 2 spaces over, but I want to discuss how to do a conversion formally. When you do a conversion, what you're really doing is you're multiplying your number by a fraction that you make out of two other numbers. And before we talk about what those two numbers should be, let's first talk about what the units in the fraction should be. What I want is for my final answer to be in the units of meters, and that means I want the units of centimeters to cancel out and go away, like this. So that means I want the centimeters to be on the bottom of my fraction, so that they'll cancel out with the centimeters in my original number. And then I'll only be left with meters on the top of the fraction, which means my final answer will also be in meters, which is what I want. So now that I've figured out what the units on the two numbers in my fraction are supposed to be, I now need to figure out what the values should be on the top and the bottom of the fraction. Well, these two numbers just get built out of an equality. How many centimeters are equal to 1 meter? There's 100 centimeters in 1 meter. So in my fraction, I write 100 centimeters equals 1 meter. So now we've created our conversion factor, which is this fraction. So now you can type this into your calculator and get the answer for how many meters is in 45.7 centimeters. And this gives us the answer that we were expecting. So now let's try something a little more complicated. Say you've got a value in meters per second, and you want to convert it to kilometers per hour. So this is actually a two-part conversion, meters to kilometers and seconds to hours. So let's convert the meters first. We start creating our conversion factor, which is that fraction of two numbers again, and then we think about the units. Because remember, we want our final answer to be in kilometers. That means we want the meters in the original expression to cancel out. So where should the meters go in our conversion factor? Top or bottom? If you said that they should go in the bottom, then I agree with you. Because by putting meters in the bottom, they should cancel out with the meters on the top in the original expression. So now we just need to fill in how many meters are in 1 kilometer. And that's 1,000. So 1,000 meters equals 1 kilometer. And now you can plug this into your calculator and see what the answer is supposed to be. And that's 4.573 kilometers per second. Of course, we're not done yet because we still want to convert seconds into hours. So I'll bring my value down here, and then we'll start assembling the conversion factors for that. Now we're going to go from seconds to minutes and then from minutes to hours. So I actually need two conversion factors here. And we still need to think about how the units are going to cancel out, because we've got seconds on the bottom of the original number. That means we need seconds on the top of the first conversion factor. Otherwise, the units won't cancel out properly. Likewise, we're going to need to cancel out the minutes also. The minutes appear on the bottom of the first conversion factor. That means we want to put them on the top of the next conversion factor. Then they'll cancel out. So again, the seconds in the bottom of the original expression cancel out with the seconds in the top of the first conversion factor, and the minutes in the bottom of the first conversion factor cancel out with the minutes in the top of the second conversion factor. And then all you should be left with is kilometers per hour, which is what we want. So how many seconds are there in a minute? There are 60 seconds per minute, so we fill that in. So how many minutes per hour? Again, there are 60 minutes per hour, so we fill that in, and now you can type this in to your calculator and find out what the answer is. 4.573 times 60, divide by 1, times 60 again, divide by 1. And the answer is 16,462.8 kilometers per hour. Or we can write this in scientific notation in order to give it the correct number of significant figures, which would be 1.646 times 10 to the 4 kilometers per hour. And this is a good time to point out something you may not have noticed, and that is that constants don't affect the significant figures. In other words, 60 is a constant, 1 is a constant. They don't affect how many significant figures my final answer is allowed to have. Only the original value did. So my original value only had 4 significant figures. That means that my final answer is only allowed to have 4 significant figures. But the constants, 60, 1, 1,000, they don't affect that.